Hello ladies and gentlemen, welcome to the portal, the mathematical science portal. This is your teacher Karabo Sehla. Today we are naming the aldehydes and the ketones. Okay guys, so the aldehydes and the ketones, they have a carbonyl group. Okay, they have a carbonyl group. So our carbonyl in aldehydes, our carbons that is connected to the oxygen, it has one hydrogen in aldehydes, and in ketones the CO group is between two alkyl groups. Okay, so the minimum ketone that we can have is propanone. So starting from propanone going up, but with aldehyde the minimum you can have is starting from methane. Okay guys, so now let's quickly name our molecules. Okay, so this one, how do we name an aldehyde? Aldehyde, the functional group, this one will always be at the end of the chain, okay, or beginning of the chain, however you may call it, but then will always be outside the chain, on the carbon that is outside. So, and for a ketone, it will always be in the middle, okay, not center. Let's say maybe you have 5 carbons and then you'll always be on carbon number 3. That's not what I'm saying. I'm saying the carbonyl group of the ketone, it must have 2 carbons all the time. It must have 2 carbons on the left and on the right. Okay, so now this one we cannot name the position of the aldehyde because it's always at number 1. Okay, so we just call the entire thing, this is starting from 1, 2, 3. Okay, so 3, the parent name that has 3 carbons is what? It's a it's propan. Okay, so now it means here we have a propanal. Remember that the suffix of the aldehyde, it's al. Okay, so now here, because this is the minimum molecule in ketones, here we don't have any other option to position this carbonyl group and put it anywhere. So now this will simply just be a propanone. Okay, so the one comes from the ketone, the 1 from the ketone, and then the al for aldehyde comes from the al of the aldehyde. Okay, don't confuse the two. The ketone own the 1, it means that its name will have a 1, and then the aldehyde, the al, will have an al as well. Okay, so now why do I introduce aldehydes and ketones at the same time? Well, it's because aldehydes and ketones, they are isomers. Okay, they are functional isomers, so they have the similar general formula of CnH2nO. Okay, so if they give you an aldehyde in an exam and they say draw a functional isomer of the aldehyde, you would draw a ketone. Okay, so now let's name a few. Let's have an example here. An example. Okay, so let's say we have hydrogen. Okay, and then now we have the carbon. Okay, let's make this one red as well. Then we have CH2, CH2, CH, CH3. Okay, Br. So now, what molecule is this under what name it falls? Okay, so my question is, if you look at this thing, look at the functional groups, look at the longest chain, 1 2 3 4 5. Okay, so the longest chain, which functional group does it have? If you look properly, it has the carbonyl group that has an H, which is our aldehyde. Okay, our aldehyde, it has a suffix of al because it's an aldehyde. Okay, so now how many carbons does it have? 1 2 3 4 5. Okay, so now we start numbering from the carbonyl itself because it's the functional group of our molecule. So then here 4, then here 5. So now the name would be what? Would be 4 bromo pentanal. Pentanal. Notice that this null, it does not have a position because it's always number 1. Okay, it's always number 1, so it doesn't have a position. So let's do example number 2. Example number 2. Okay, if I say CH3 CH2 CH, then here CH3 CH3. Okay, and then do I have in here and my hydrogen there? So now always the aldehyde functional group is number 1, the carbon is number 1. So naming from right to left, 1 2 3 4 5. Okay, so now I have 2 methyls at number 2 and number 3, so I would have 2.3 dimethyl, 2.3 dimethyl pentanal. Okay, that's all there is to it, guys, about aldehydes. So let's talk of ketones. Let's talk of ketones. Let's have our examples of ketones. Let's say this is example number 3. Okay, so now let's say we have 1 2 3, 4, 5. Okay, and then let's say our carbonyl is here, right? And then now, okay, and then the rest is just hydrogens. Okay, so now when you are naming a ketone, the carbonyl group, it can be anywhere in a ketone. It can be here, it can be here. Okay, so we have to number its position. So when we number from the nearest end, again, we can't start from left to right in this situation. We must start from right to left. So we'll have 1, 2, 3, 4, 5. Okay, so now if you check our parent chain, 1, 2, 3, 4, 5, it's a what? It's a it's a pentane. Okay, but now we have a ketone, so it's a penta. It's a pentanone. Okay, so and then now the position of the ketone functional group is what? On number 2. So we can say it is a 2 pentanone. Okay, or we can say pentan 2 1. That one from the ket one, you see, ketone, you see, pentan 2 1. Okay, so now this is the name that we want. Let's say example 4 now. Example 4. So example 4, let's say we have CH3, CH2, CH2. Okay, let's have our carbonyl here, and then let's have a branch there, another one here in the CH3, then another branch here. So now what will be the name of this? So now we must name from the nearest end, right? So from this, from left to right, I have 1, 2, 3. So my aldehyde, not aldehyde, my ketone functional group is number 3. But if I count from right to left, 1, 2, 3, 4, it's number 4. 1, 2, 3, 4. So now it means here this is 1, 2, 3, 4, 5, 6. Okay, so now I have how many methyl groups? I have 3 methyl groups. The other one is number 4, and then I have the other one is at 5, and then the other one is also at 5. So 4.5.5 trimethyl hexane. Then the position of the ketone is number 3. Okay, 3 1. So 4.5.5 trimethyl hexane 3 1. Okay, or you can say 4.5.5 0.5 tri methyl dash 3 hexanone. Okay, and then that's all there is to it, guys. I will put activities for you to do. I will create a quiz for you to do. So just to make this video shorter and not make it any longer, I'll create a quiz for you to do, and then from here what is left, I think what is left is esters. Yes, esters, because for now you guys, I think you are not doing ethers, so I have not seen ethers here. So let's do esters in the next video. Okay, thank you guys.